नमस्ते बच्चों, हमेशा खुश रहो बच्चों। Myself Om Prakash Kesari, Faculty of Department of Science and Technology under Faculty of Education and Mathology. Today I taught you topology, in which we have discussed some topic on topology of R. The subject topology is taught in MSc Mathematics first semester student. Once again, namaste bachchon. The lesson plan is already discussed in your introduction class. Step for planning a lesson is already discussed in your first lecture class, and the components of a lesson plan is also discussed in your first lecture class. Now, I'm going to deal with the subject topology under mathematics, which are the subject of science and which are taught in MSc Mathematics first semester student. In your previous class, I will see some basic definitions such as neighborhood, delta neighborhood, deleted delta neighborhood, and open sets, and as well as closed sets. And I also discussed that the complement of open set is closed set and the complement of closed set is an open set. Now, recapping all these things in short period of time. Neighborhood. Neighborhood is nothing but the area lies between the point, the area which are covered by a point with a small positive value delta. That means P minus delta to P plus delta. P varies from P minus delta to P plus delta. The reason behind this is called the neighborhood of the point R. That means next one is the deleted delta neighborhood. Deleted delta neighborhood. That means if we delete the point P from the neighborhood of P, then this is called the deleted delta neighborhood of P. Next one is the a point P is said to be interior point of G if there exists a delta greater than 0 such that neighborhood of P is the subset of G. Neighborhood of P is the subset of G. And the collection of all interior point is called the interior of G. And if interior of G is equals to G, then we say that the set is open. Otherwise, otherwise closed. That means the complement of open set is closed. The complement of open set is closed. Now we will move further. The following sets are the example of closed sets. I will already discuss that phi and R are also closed set as well as open set. I will see that in previous example, phi and R is a closed set, but phi and R is also an open set. Phi and R is also an open set. That means the entire set and the set itself is closed as well as open, or we can say open as well as closed. Any finite set, give example 1, 3 by 2, 2 is closed. Any closed interval is closed. Union of closed interval is also closed. The above observation led to the following results that phi and R are closed sets. Arbitrary union of closed set are closed, but finite intersection of closed set is closed. Similarly, I will see in the open set, phi and R are open set. Arbitrary union of open set is open, and finite intersection of open set is open. Here the point will be noted. Arbitrary union of open set is open. Arbitrary union of open set is open, but the finite intersection of open set is open. And here any closed interval, sorry, arbitrary intersection of closed set is closed and finite union of closed set is closed. That means just opposite. At that, arbitrary union of closed set is closed and arbitrary intersection of union, and here arbitrary union of open set is open, arbitrary union of closed set is closed. Arbitrary union of open set is open, arbitrary union of closed set is closed, and finite intersection of open set is open. Finite intersection of open set is open, and here finite union of closed set is closed. It may be noted. That means just opposite. That means arbitrary union of open set is open and arbitrary intersection of closed set is closed. But finite intersection of closed set is closed and finite union of closed set is closed. The notation of closed set can be arrived at yet through another approach. That means in another way. Now let us define one more important points which are known as limit point, and it is also known as accumulation point. And this is very interesting point because when we go to anywhere in interview, anyone asks that what are the difference between limit and limit point? What are the difference between limit and limit point? Let us see what are the difference. A point P of R is called the limit point. A point P of R is called a limit point or an accumulation point of a set F if every delta neighborhood of P intersects F. Every delta neighborhood of P intersects F at least one point other than P. At least one point other than P. That is the deleted delta neighborhood of P intersects F. That means the deleted delta neighborhood of P intersects F. A limit point of a set may or may not belong to the set. A limit point of a set may or may not belong to the set. Let us understand these things with the help of an example. For example, the set 1, 1 by 2, 1 by 3, dot, dot, 1 by, and dot, dot, to infinity has a limit point 0. Has a limit point 0 which does not belong to the set. Which does not belong to the set. Because 0 is not there in the set. On the other hand, every limit point of 0 to 1 belong to the set. Every limit point of 0 to 1 belong to the set. That means every point of the set is also a limit point. That means every point of the set is also a limit point. The set 1, 2, 3, 4, 5 has no limit point. The set 1, 2, 3, 4, 5 has no limit point. The set of limit point of a set F is called derived set of F if and is denoted by F star or derived set of F. The set of limit points of a set F. The set of limit points of a set F is called the derived set. That means the set of limit points of a set F is called the derived set. That means collection of all limit points. The collection of all limit points is called the derived set. In simple, we can say a set F of R is called closed if a set F of R is called closed if F complement subset of F. That means every limit point of F is contained in F. If every limit point F is contained in F, then we can say that F is closed under R. F is closed under R. Thus, 0, 1 is a closed set. 0, 1 is a closed set since every limit point of 0, 1 is the limit point of 0, 1. The set F union F complement is called the closure of F. Is called the closure of F and is denoted by F bar and is denoted by F bar. And it is straightforward to prove that F is closed if F equals to F bar. F is closed if F equals to F bar. That means I will see in previous class the G interior is equal to G. Then G is open. Similarly, F equals to F bar. F equals to F bar, then F is closed. G interior equals to G, then G is open. F equals to F bar, then F is closed. Note that we could have started with the definition of closed set in this way, the and thereby arrive at the usual topology. Arrive at the usual topology through open sets defined as components of closed set. Open sets defined as the components of closed set. The question variable, an infinite set will always have a limit point, is settled by the following result. Is settled by the following result, which is known as the Boltzmann-Wechsler theorem. Which is known as Boltzmann-Wechsler theorem, and this theorem is very important and very simple. This theorem is very important and very simple. Every bounded infinite set has a limit point within or outside the set. That means every bounded set, that any bounded set which are any set which are bounded has a limit point. Has a limit point within or without with outside the set. Within or outside the set. That means the limit point may be inside the set or may not. May be inside the set and may not. Now let us define some basic terminology also. The first one is the sequence. The first one is the sequence. A real valued function whose domain is n, that means natural number, is called a real sequence or simply sequence. Often the range of such function will be referred as a sequence by convenient and will be denoted by sequence of action. A sequence action is said to be bounded if its range set is bounded. If its range set is bounded, that is, if there exists a real number k such that mod action less than equals to k. That means action varies from minus k to k for all n. For all n. Thus, for example, 1 by n plus 1 by n, and minus 1 to the power n are example of bounded sequence. A sequence action is said to be convergent if there exists a real number L. If there exists a real number L satisfying the condition, which what condition? That for every epsilon greater than 0, there exists a positive integer n naught. There exists a positive integer n naught such that x mod xn minus L less than epsilon for all n greater than equals to n naught. For all n greater than equals to n naught. The number L is called the limit of the sequence action. The number n L is called the limit of the sequence action. Note that the above definition expects that every delta neighborhood of L contain all but finitely many terms of the sequence. All but finitely many terms of the sequence. This session is powered by the digital version 2.0 JAYOTI VIDYAPEETH Women's University, Jaipur. And I hope all of you are satisfied with my digital session, and if you have any queries, please mention in the comment box. I will try to resolve it. Thank you, Acho. Thank you for watching my this lecture video.